All right. Hi guys. Sorry for being late. Um, are you ready for to go on?
Yes.
Any questions? Yeah. Sorry for actually I haven't been able to find out what's wrong. So I actually think something wrong with options because I can find um, any wrong about the logic. So actually, I think something wrong about the options. So I'm going to review this problem in your test, and if something incorrect, we will provide you with additional feedback and the grading scheme will be corrected. Okay, because actually, what solution that I'm providing actually says that other option is correct. Actually, two other options is correct rather than that um, is correct by default. All right. Okay. So let's not waste time here right now because you're not going to miss anything regarding your test. So let's move on to problem number three. It's kind of very easy one, I think, because it deals with um, actually extracting the parameters for backtesting from the verbal information, right? So if you don't mind, someone please share your thoughts on problem number three about the backtesting and defining the zone of the big testing and the traffic light. So Nikolai says he has no solution on that. Someone else?
I can show solution.
All right, great. Anna.
um, so, firstly, I um, counted how many months was in 10 years and described nine times such a hit was occurred.
Mm-hmm.
And another measure is expected frequency, one in 24 cases, uh, one time in 2 years. Then I uh, compared it with the help of test and applied function. So I got an answer that p-value 6 oh 06 and the zone is green, so model works nice.
Okay. Yeah. So generally, I agree with Anna, and the answer is correct. So the basic idea. Let me repeat what um, Anna just said. Just uh, let's conceptualize it a little bit deeper. All right. So the basic idea of the problem is to determine the parameters of the binomial test, which lies in the ground of the backtesting, right? So basically, we have three parameters there. One of these parameters is number of observations, right? So all the cases where when we compare risk measures with realized losses, right? So we talk about VAR. So we need to find uh, how many observations we have where we have VAR and we have realized losses, and we are actually um, able to compare those numbers and define if the day we consider is unlucky for us and we experience losses greater than VAR, so we're in extreme zone, right? Or everything goes according to the plan and we see profits or losses not that great than var, right? So we pretty secure. Okay, so what we have from, what we can learn from the text, we learn that we have 10 years of information, right? And we know that frequency of the data is monthly, right? So actually, number of observations is proportional to the uh, months per year, and this is the constant, right? So 12 months per year, and how many years of observations we have, right? So the n number, number of observations that Anna calculated here is just 10 multiplied by 12, right? So we have uh, 120 observations, right?
Uh, yes.
Okay. So the
No,
another
no.
parameter.
Yes,
Hmm?
yes.
So
120.
okay. So another parameter that we need to specify is the number of experiments that bring us losses, bring us more losses that var uh, may represent. Okay, so this is very easy to understand as well. It is clearly stated from the text that we observe 9 observations, right? So just 9 times. Okay. The more tricky one is to identify the p-value, so the value of probability of extreme losses, right? So actually, this parameter represents um, 1 minus level of the value at risk, right? And this value is not specified here. So we actually do not know the exact confidence level that was specified by analyst. But at the same time, we know something about expectations of observing losses greater than var, right? And that's what actually represents 1 minus level. So this is the probability of extreme events. And what we can learn from this text that we expect to see on average 1 hit per 2 years, right? So here is the p-value. I mean not p-value, but probability of success is clearly 1 divided by 24, right? So 1 case per 2 years, that means 1 month, 1 monthly um, losses over var that we expect to see in 24 months, right? So this is the probability that we're seeking for. Uh, and absolutely correct that that specifying alternative hypothesis in this test is a greater, because by the so we can see in the text that we're talking about one-sided binomial test, right? But please remind me what exactly means to carry out one-sided tests. What um, hypothesis we're trying to test, or at least what alternative hypothesis that we tested.
Mm, are we trying to test that in reality uh, it, it should occur with the probability of 1/24 uh, or more
Mm.
rarely.
Mhm.
Yes.
Okay, so that means that actually we're trying to identify if there if losses greater than var occur much more frequently than we expect from the assumed um, confidence level, right?
Mm,
So we're just concerned about underestimation of risk, right?
Yes.
Okay, yeah, that's great. So absolutely correct. Yeah, and the all the steps that Anna took solving this problem, absolutely correct.
Okay.
I have one more question for every one of you. Assume that we have alternative model. So actually, we running this back test on two models. And for example, for another for another model, we have p-value around 30%. First of all, what we're going to conclude on that model. So what would be a result? So how we will interpret this result in terms of quality of the model. And if we compare these two models, so this one with a p-value of 6% and another model with 30% p-value, which one of those we will pick for the final for the final decision for application, and what the reasoning? Okay, so we have p-value for this model 6%, and Anna said, okay, this is a green zone. At least what we see from
Maybe it's no matter which model to choose, as they both show good result.
so they both show good results, but basing on p-value that we observe, one of them is 6%, another one 30%. Can we make a choice between those models? Is it correct? So for example, will I prefer model with a greater p-value over model with less p-value?
We should not really prefer it, but we are more certain about it.
Why do you think so?
Because we don't reject the null hypothesis with the
In both
greater
cases, in both
yes,
cases.
but in one case with the lower probability of error, and in another with higher.
Um, and that's what I would like to emphasize right now. This is the greatest mistake that you can make dealing with a backtest. Because as a matter of fact, dealing with the p-value, everything that you can learn uh, from from the hypothesis testing is whether, according to your power of the power of the test, so the probability of a first type of mistake. So you actually can prefer one model over another one only if one in green zone and another one in other zone. So when they in one zone, you cannot compare p-values because actually they both comply uh, with um, with the confidence level and the power of the test, but which one of them are graded do not specify and not determined by the p-value itself. It's very easy to understand. Try to run a lot of um, um, ex- experiments using only one model. So you just regenerate your observations. You definitely going to see different p-values, right? Just because of sample. And you still use one model. So difference in p-values actually do not say uh, difference differences in p-values say nothing to you. It's just a matter of chance. But every time when you see um, when you observe rejection of null hypothesis, you actually um, making a conclusion according to the power of the test. So, for example, if you leave 5% for the chance of rejection, okay, so that's what you do. So that means that if you try to um, compare those two models just in terms of p-value, you only can prefer one of them over another if one of them passing test and another one does not, right? So if they pass together, what you can say, they both valid, at least that's what my data says. I'm not sure which one of them better because I know that picking another sample, probably I see them both passing this test again, but with other p-values, right? And what am I supposed to do now? Having another p-values. Should I switch between them again or not? So that means that you need another criteria, maybe not related to p-value at all. So for example, you would pick a model that passes another test, or you pick model that is simpler in terms of structure, all right? But that's very important to know. Never prefer model one over another basing on p-values, all right? When they're in a one zone. So if both models passes, you cannot say which one of them better than which one of them better. If they both do not pass, that means they both invalid, and you do not need to go into details to determine which one of them are more useless than another one. Okay, all right, is that clear?
Yes, it is. So we should not even compare them if one of them is in a green zone and another in a yellow zone, right?
So when one of them in a yellow zone and another one in green zone, you can say, okay, if I'm picking model that in a green zone, I definitely know uh, the model that in a green zone is going to be my choice. So I know that the yellow one, okay, it's definitely not that attractive to me because the data rejects my initial expectations about the quality of this model, right? But if I see two models in a green zone, I say, okay, probably I should toss a coin to make a choice, or I should um, bring another criteria. So this secondary, supplementary criteria, which has nothing to do with p-value. Okay, maybe that might be another test, for example, like test on independence. That might be just preference uh, based on complexity of the model. It might be uh, absolutely practical criteria, like for example, I have already, for example, I have one model implemented, right? And it's still valid, and I have another model that is valid, but I need to invest money to implement it and integrate it in my analytical system. So I'm going to stick to model that already implemented, right? And prefer not to um, uh, suffer any costs, suffer any additional costs, right? Just to replace a model that works fine, right? All right. So, but based on p-value, based solely on p-value, you never can do this choice if both models in a green zone. Hmm? Great. So now let's move to problem number 4 and 5. They are both connected, and so I think we can look at them together because one of them one step away from another. Okay. Okay. First of all, let me put the solution for um, this problem. Let me delete all the comments. And change it to level versions. Okay, so here's the problem. So here are two problems. We have some code that simulates dynamics of some stock index, and we have another piece of code representing 1-day value at risk for positions invested in this index. All right. So 1-day var, meaning that it's just 1-day horizon. Okay. And we have some observations for the following days. The idea of this problem, of this task, is to practice dealing with constructing observations. All right, so we need to identify a number of observations where we can compare value at risk and realized losses, and find number of hits. All right, so can anyone show the solution? Come on.
I guess they were just much harder than first and the third one.
Well, it's okay.
I can show.
Okay, we are ready.
Mhm. One moment. It's the fourth task. So the generated code, there's index. You can see its graphic. I draw it, and that code generates values at risk. It has such a graphic. Then I just merged. Then I calculated returns. Now I should find where did I done it.
Okay. So you just took the difference between.
Yes, differences.
Okay. Oh, you
between-
apply. Okay, so you applied log return concept, right? So you just calculated logarithm and then just took their difference.
Yes, I decided to
Okay.
calculate log returns as the amount of such prices indexes will correct on one. So now
Okay.
we have 88 with one none, so 87.
So you drop the first observation without any number, any particular value. Okay.
Yes. Then I stay with the same bars, and then I just merged these series with indexes and with bars, and got that there are 64 rows which contain no none, and that's our goal.
Cool. All right. And so now we need to combine this information together so we can construct so we actually can construct observations containing risk assessment plus realized losses, right? And at the same time, we need to take into consideration the problem of dimensions, right? In the units, because one of them expressed, some of those observations are expressed in terms of basis points, right? And another one in terms of just relative values returns, right?
Yes.
Okay.
As I understood, index codes are was in some strange percent format, and we should multiply it by 100, and vars are the number that after point
Uh-huh.
40 means uh,
So,
how it can be said.
so 50 points means half of percent.
Yes, yes.
Okay.
And they should be divided by 100.
Right.
And then after this correction,
Uh-huh.
we got the same format of numbers, and then we check how many rows are how many rows can uh, take this assumption that
Uh-huh.
uh, that
Uh-huh.
this difference is less than value at risk. So there are 6 rows where we can see hits
Yeah,
for
but how you deal with the fact that value at risk is positive here, and your returns are um, and the data, the P and L actually represent losses with the negative values.
uh,
Yeah, I see it from the
we
code. Just please articulate it for everyone.
yes, we should check that difference is less than vars with a minus negative var,
Yeah,
and
yeah, because
as they both uh, mean losses, so it should be minuses there.
yeah. So first of all, what we have to understand here, we have to understand here that basically uh, the raw data here is represented by returns, so the negative values are actual losses. So if you apply this inequality check um, for var data without multiplying by -1, what's going to happen? Actually, you're going to see what? A lot of hits, right? Because, or not, or less hits.
We observe 6 hits.
Yeah, you observe 6 hits here because you apply this
Yes, but
inequality
but
correctly. But if you do this incorrectly, you're going to observe tons of losses, right?
yes,
Exceeding var. So you actually going to observe losses because actually var without correction for -1 will represent profit, right? So when you can apply this comparison without correction of var, you go into observe a lot of hits, right? Because value of the var is positive, and at least in half of the observations you observe losses, right? So you're going to see enormous portion of hits, right?
yes,
And that will mislead you on um, the conclusion of the quality of the model because you're going to observe a lot of hits without this correction, you might be wrong about the fact that your model actually underestimates risk and you face a lot of hits, right?
You mean without minus, var without
Without
minus?
minus. Yeah, because
I
without
can
minus,
show.
you're going to see a lot of hits.
We can see. Uh, mhm.
Yeah, here. So you can see 61. Yeah, but that means, so if you deal with this data, you go into make a conclusion that that the quality of your model is very poor, right? Because you underestimate your risk a lot. But usually when you face a lot of hits, that means that you do something wrong. Probably you something miss on a stage of calculation of var. So for example, you're on the wrong side of the distribution, or you might lose some uh, um, for example, unit corrections, like here where we have losses expressed in terms of um, basic points, because if you do not correct it like as you did, so probably you're going to see no hits at all, right? Uh, because the scale of the observations of R are much greater than the scale of returns, right?
Yes.
Good.
It was the first time when I tried to do it.
Yeah, but you did correctly, because I mean this is the right answer.
Okay.
So the key feature of this task um, is the combination of the information. Could you please show us again how you did it? So you applied merging, right?
Uh, yes.
So you merged tables somewhere, right? Could you
First,
yeah, could
first
you explain? No,
merging.
just please explain to the audience what the merging means
I just try to
and how it
find
works.
rows where value is some number but not none. I can observe some rows in series with with percent changes,
Uh-huh.
and uh, in vars there are no none,
Uh-huh.
but there are different dates
Uh-huh.
in these two series as they take different period. For
Mm-hmm.
example, index starts at May, and
Absolutely.
var starts on June.
Mm-hmm.
So some dates are missed in
Mm-hmm.
vars, and we should find just rows that contains both indexes and vars.
Right.
We make merging that finds uh, not none values that contains both dates, and we get 64 rows, and that's the
Great.
code of merging.
Uh-huh. So what this line actually means with the PD merge, let me just explain it to the public as well. So actually, what this operation does is finding matching index values, so the same dates, and combine those observations from two tables together, right? So this is the matching by dates, okay? So if some observations in table number one, like dealing with rates, with the returns, um, um, if this table contains some observations without opposites in vars tables, that means matching cannot be done for those rows, and they just omitted. All right, so they are not going to be in the resulting table. The same works in terms of var models. So for example, if you have some observations when you know var, but you don't know the value of actual return, So this date and this observation will be dropped as well. Okay. Um, Actually, you can modify the um, merging comment and allow for including those observations without pairings. But at the same, but in this case, we actually need this inner joining, right? So we just need intersection of the index of two tables, right? Because we need all only observations with the full information. And um, that is executed perfectly here. So Anna is a great job, has done a great job.
Thank you.
And the only thing that I would like to mention here is the way you calculate um, P&L, so returns. So I would like, so if you don't mind, please scroll above again, scroll up again. Um, the part when you calculate the returns. Okay, so what we have to keep in mind here is that diff is taken according to the sorting of the table, all right? Because here we can see that observations goes from older to newer, right? So if this table is sorted other way, or you have another index without dates that can be automatically used for as an index for taking difference, please be very careful when you calculate returns, because you should calculate returns taking price today and using the price from yesterday. All right. So when you calculate returns, you should use difference between price today and price tomorrow, or ratio of today's price to the ratio to the price yesterday. All right. And I said tomorrow, right? No. So let me be clear again. So when you calculate returns, you relate today's price to the previous price. So this is a price from yesterday. All right. If you see the table that's sorted from newest dates to oldest ones, and you apply methods like diff, actually you may face some troubles because you misrepresent returns from future to the past. Okay, so please make sure you relate correct price to correct one. So it works from today and it relates to yesterday. Okay.
Okay.
Okay, because you open your position with a previous price and you realize losses from changing price from yesterday to today. So for example, if you observe return, uh, missing those dates and reverting them in other order, you may face loss rather than profit. Okay. So please be careful with this all the time. All right, Anna, I think it's a great job. So everything is correct. If you don't mind, I would like you, for the purpose of saving time, could you please share with us the link to your collab?
Okay.
So
I will print
actually,
it in the chat.
I genuinely encourage of sharing materials among the students. I think that's something that most of the teachers uh, consider as a crime, but I don't. I think it works pretty well. Uh, so I'm okay if you share this with your colleagues. Okay. Dmitry says no access.
How can I open
Okay,
access?
okay, okay. Let me show you. I demonstrate my screen. Okay. Okay, so Look at the right upper corner of your screen.
Mm-hmm.
You can see the button share, so the share notebook. So you can hit the key and you going to observe this window. What you
Mm-hmm.
have to do, you have to um, activate the general access. Probably you
Okay.
should hit something here, and you're going to see anyone with a link is a viewer. Okay,
Okay.
and then you copy a link and put it into chat. I think the link is not going to change, but now new settings will be associated with it. Okay.
I opened it.
Okay, let's see. Let me check it as well. Yeah, it works fine. Thank you. Yep. Great. 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 All right. So, um, okay, I think we can have test now. So let's do it this way. We're going to have 5 minutes break. I'm going to coordinate my actions with Zina because uh, she holds another seminar right now, and we just synchronize our tests. And once we're done, I'm going back on air and announce the that test starts. So what you have to do right now to be prepared, please go to the Smart LMS, open section Market Risk, and test for you is going to appear right there. Okay. So we going to set extended period of time for the test. So I mean, it's going to be active um, like like 40 minutes maybe. But once you start, um, you're going to have 30 minutes for the completion. Okay. All right. So 5 minutes break. All right. And I'm back. Okay, I'm back. So the test is on. Whenever you're ready, you can start and complete it. You have 30 minutes for completion. There are just 5 questions, 2 of them numerical, so uh, you're gonna need to do some calculations. They're not very hard, and you also have mm, 3 theoretical questions. We addressed those questions today, so actually you have the answer. Probably you should generalize it from what we've been discussing today. Okay, so you have 30 minutes. Um, you can use anything you like, so it's an open book test. Um, by the way, I cannot control you. The only thing I would like politely to ask you is to do your own test by yourself. So just do not copycat anyone. All right. So you can use any material, you can use internet, but please just try to use your own intellectual abilities to identify the answer. All right. So good luck. I'm going to be here for your questions during the test. If you have any question, you can write it in chat if you're hidden from the air, or just turn on your mic and speak out loud. I'll be right here without with the camera on, so you can see that I'm here. So the best of luck. Off you go. One more hint. Please note that the time of the test is running on the right hand side of your screen when you work in with the form. All right, so you can control your time.